All right, let's collectively breathe a sigh of relief. Item number 1. There's one video left. This is the last one. Item number 2, we have difference of squares. And somehow, for me, difference of squares is way easier to visualize than factoring quadratics that are trinomials. For me, this is a little bit more simple. So let's solve these two difference of squares. Here's the thing. Precalculus and precalculus decimals and fractions are not created equal. We don't love to see decimals in our factored form, but we can see fractions in our factored form. So what we're going to do with this one is we are first going to factor out 0.01, so 1/100th. So what we're left with here is 900, heyo, x squared minus 64y squared. I think you're seeing where this is going here. What this one can do is 0.01, open the bracket. So we have 30x, 30x, because the square root of 900 is 30. And then we have a plus, and we have a minus, and then we have 8y, 8y. And what we can do is we can factor out a 2 from each of these. So what I'm going to do is I'm going to say 0.1, and I'm going to open up a square bracket, and I can take out a 2. What I'm left with here is 15x plus 4y. Whoop. And I can factor out another 2 from this one. 2. 15x minus 4y. Whoop, whoop. So then I can say, okay, 0.01 times 2 is 0.02 times 2 is 0.04. And then I'm left here with 15x plus 4y. 15x minus 4y. I know. Totally not fair, because we're going to get to this one, and even though it's fractions, it's going to be way easier to conceptualize. So with this one right here, we have whoop, 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 whoop. So we're going to get x over 3, x over 3, because the square root of x squared over 9 is x over 3. We're going to give one a plus, we're going to give one a minus. And then this one, the square root of this one, the square root of 4 over 25 is 2 over 5. 2 over 5. And we're done. So very similar question, but because we don't love decimals in a factored form as our factors, there's a little bit more work, but this one's pretty easy. What about this one here? So before, we were letting a polynomial expression or a binomial equal some single letter. Well, what happens if we did this twice? What happens if we let a equal 2x minus 1 and we let b equal y plus 4? Now you might be thinking, do I really need to define my variable? Heck, yes you do. Because who's to say, if we literally want to write down this equal sign, that means that we have to say that the first line is equal to the second line. If we're just introducing a's and b's without defining them, how do we even know? How do we know? We don't. So what I'm going to say here is, instead of 2x minus 1 squared, I'm going to say, a squared minus y plus 4 squared, oh no, minus b squared. I know how to do that, no problem. A plus b, a minus b. But since we have the equation in x's and y's, we need to, or since it's not an equation, it's an expression actually. Since the question is stated with x's and y's, the answer should also be. So we want to sub back. Okay, this right here is not a mathematical statement at all. It's just kind of a helpful little note. So I'm going to whip out those square brackets again, And anytime I see a, I'm going to write 2x minus 1. 2x minus 1. Anytime I see b, I say y plus 4. The reason why I'm putting them in brackets is not because of the addition factor. It's because of this factor right here, because there's a negative. And you'll see what I mean in a second. So a is 2x minus 1 minus, and then b, which is y plus 4. Now, if you don't put the bracket around it, my gut is telling me that you might forget to use your happy little rainbows to distribute this negative to both of those terms. So I can drop the brackets now, so I have 2x minus 1 plus y plus 4. Oh look, I have some constants that need combining. I have 2x minus 1, ooh, minus y, ooh, minus 4. Okay, so I'm going to just clean this up a bit. 2x plus y plus 3, because 4 minus 1 is 3. And I have 2x minus y. Negative 1 minus 4 is minus 5. Boom. Done. Let's do another one, shall we? This one's a bit of a trickier one because we have a coefficient in front of something that we would like to... we have a coefficient in front of a variable that we would love to substitute for. So should I say p and q? So let p equal 2t, 2t for t, plus 1, and let q equal s minus 2. Now, if I were in high school, I would be like, what's magical about p and q and a and b? There's nothing magical about it. I'm just really pulling it out of a hat here. I'm just making this up. Okay, so the p and the q, you can use whatever letter you want. I'm just choosing p and q. So now we're going to substitute that in. So 9p squared minus 4q squared. I'm going to do my I'm going to do my difference of squares thing. So 3p minus 2q plus 2q. Notice, just to switch it up, I switch the order, just to keep you guys awake. So now what I need to do is I need to substitute back the t's and s's. So I'm going to get out my square brackets because it's just easier to organize. So I'm saying 3, and instead of p, I'm going to write 2t plus 1. 2t plus 1. Minus 2, instead of q, I'm going to say s minus 2. Close bracket. So I have this entire bracket here. Now I'm going to expand again. So 3 times p, which is 2t plus 1. Plus 2q, which is s minus 2. Close bracket. Now I'm going to distribute the 3's and the 2's accordingly and make sure that I'm paying attention to negatives. So I'm going to say 6t plus 3 minus 2s plus 4. That's the tricky part. The rest of it should be okay. So then I have 6t plus 3 plus 2s minus 4. And now I'm going to clean up those constants. So I'm going to say 6t minus 2s plus 7. 6t plus 2s minus 1. Great. All right, one more. Don't let this one trick you. Yes, indeed, it is a perfect square, or it is a difference of squares. All we need to do is we need to factor out something that's common between these, and you'll see real soon. It's just kind of upping the ante a little bit. And when I say a little bit, I mean maybe a lot. So what I can factor, I was about to say download. Nope, not downloading. We're factoring here, folks. I can factor out a 2 from both of these. So I say 2, and then I'm gonna use square brackets. And so, just side note, brackets, square brackets. Ooh, dun, 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 dun. Those are Alfred Hitchcock brackets. It's not really, but they just look like a profile of his face. You don't know who Alfred Hitchcock is? Google that. So if I use these brackets, it means that I need something more than the square brackets will allow. But I don't need that quite yet, I don't think. So 2, and then I have 32 divided by 2 is going to be 16. And then I have x plus 2 squared minus 18 divided by 2 is 9. 2y minus 3 squared. Oh my goodness. Look at this. 16 and 9. Those are perfect squares. So I'm going to say let. You know what? I like my a's and b's. So let a equal x plus 2. I'm going to say let b equal 2y minus 3. I'm going to substitute back. So equals 2 times 16. Oh, I don't even need this one. I can use the round brackets. 16a squared minus 9b squared. All right. I'm just gonna see the let statement. So 2, and then I have 2 different brackets here. We have 4a plus minus 3b. Now we want to substitute this back. 2 looks like we don't need those Alfred Hitchcock brackets anyway. 2 times 4a, but a is x plus 2, plus 3b, but b is 2y minus 3. And then next one, 4a, which is x plus 2, minus 3b, so minus 3 times 2y minus 3. And just remember, we're substituting them back in brackets just because this this negative could really throw us for a loop if we don't contain it. So 2 times, open bracket, so 4x plus 8 plus 6y minus 9, 4x plus 8. Ooh, negative 3 times 2y is going to be negative 6y plus 9. And we can do a little bit of cleaning up here. 2 times 4x plus 6y. 8 minus 9 is minus 1. And then our last bracket is going to be 4x minus 6y. 8 plus 9 is plus 17. And we're done! Whoa, look at that. That's a lot of factoring that we just did. But remember, when you see things that are a little bit too complicated looking, first things first, see if you can factor out a greatest common factor. Okay? But also, you can substitute in variables as long as you define them to begin with.